The question says, what is equilibrium? What is equilibrium?
السلام عليكم ورحمة الله وبركاته.
عليكم السلام ورحمة الله وبركاته. How are you guys? How are you, Muhammad? What is equilibrium? No, not constant. Not constant, Muaz. When the reactant and the products are in what? You mean the concentration? If you mean the concentration, it will be right. When we reach a point where the concentration does not change of reactants and products, this would be right. But there is a definition for equilibrium, guys. R in concentration? No, not this one. What do we mean by R in concentration? We have a definition for momentum. We have a definition for momentum, guys. This was 7.5. Let's see it. Equilibrium, that's it. I'm sorry if I said. Equilibrium, that's it. The state which the forward and reverse reactions, or the forward reaction and the reverse reaction, a change takes place at the same rate. They have the same rate when the rate of chemical forward reaction equal to the rate of backward reaction. طيب سؤال تاني اللي احنا اتكلمنا عنه امس ونتكلم برضو عنه النهارده. We'll talk about it again today. عضلة الإحلام, the state in which the forward and the reverse passes should take place at the same rate. برافو عبد الله. The question says, what are factors that affect equilibrium? Is the state approach forward as equal to the reverse reaction? Yes, the rate. You have to write here the rate, Muaz. Pressure. برافو عبد الله الدهلان. Pressure. This is one. What else? Muaz, pressure. Only pressure? Pressure, concentration, and temperature. برافو عبد الله الدهلان. Concentration, Muaz. عبد الله عبد الباقي, temperature, yes. So we have three factors that affect the chemical or equilibrium. Chemical equilibrium, they are the temperature and the pressure and the concentration. And we said that these three factors follow a rule. What is this rule? What we call this rule? What is the name of scientists to describe how it works? The scientist was called Le Chatelier. And how they act, it's called Le Chatelier principle. Who can tell me what is Le Chatelier principle? That's it, Le Chatelier. Yes, what is this principle? What is Le Chatelier principle? What is Le Chatelier principle, guys? Yes, what happens? Complete. When the system experiences a disturbance, what happened? That's when the system experiences a disturbance. Yes, continue. What happens next? This is the same like the previous one. What happens after that? Such concentration to pressure changes, and it will respond to restore a new equilibrium state. Yes, it will restore. Yes, it will activate, or it will move in the direction that will restore, or opposite only will respond to restore. What we call it, it will activate itself in the direction opposite to what? Opposite to what? طيب. When a change is introduced to a system, the equilibrium shifts to the direction that reveals the change. Bravo, that's the answer. That reveals the change. Okay. So that was Le Chatelier principle. We will go over the same rules, and we will apply more of examples on Le Chatelier principle today. When a change is introduced to a system, an equilibrium shifts to the direction that reveals the change. When a change is introduced, that's it. Okay, you type it twice. You make it Control V twice.
السلام عليكم.
عليكم السلام. How are you, Ibrahim?
I'm fine, thank you. How are you, teacher?
I'm fine, thank you, Ibrahim. So let's start with. Okay. Some of you will read with us. Abbas. Yeah, Abbas. Talk from the beginning about equilibrium and Le Chatelier principle after that. Yeah, Abbas.
Mister, can I do the project?
About
Can
what?
I do the project on Thursday?
Yes, you can, no problem.
Mister,
What is the deadline? The deadline. The
Deadline.
deadline.
After 3 weeks, including this week.
Okay,
Mister.
good,
So you can
good.
say 2 weeks from now.
Okay.
What's the project, Mister?
I uploaded a video that on the Classera. Did you see the video? If you go to Classera, we'll find a video. I uploaded in the previous, I think, Sunday, and it says how to make the project. Go and listen to it, and you will know how to make a project and how you choose the topic. Okay?
Mister, I have
You will
finished
not-
the project. I will send it today, okay?
Yeah, the project. ثانية واحدة. There's someone. What is the project? Is a presentation? Is something you write it?
I write it, Mister, and I wrote something with my hand.
No. I didn't ask for research. I said no research, no presentation. I want something physical. Go to listen to the video and see it. See it once more time. Watch it. Sorry, watch it one more time. Understand what I'm looking for. And I'm asking for something modeling or something that you can touch it, physical thing. مجسم. Okay. Okay. عبد المجيد فرهودة. عبد المجيد فرهودة.
Yes, sir.
عبد المجيد, I want you to let me stop this first. You have to. It's okay. This. This. And I want you to read this slide. Read the slide, Abdul Majid.
Suppose that every time a car passes by a toll booth in one direction, another car passes through in the opposite direction. Then the number of cars on either side of the toll plaza is
Yes. So you see this toll booth this one, this is a tall path, we call it. And suppose that car moves in one direction. Let me take it here and explain it to you. This picture explains the meaning of equilibrium or mechanical equilibrium. So this picture is explaining the meaning of equilibrium. This thing is called bath toll, this one, or toll or barrier for cars to pass through it. It is called toll booth, okay? And suppose one car from here, we will suppose that this car, for example, will move in this direction, okay? And the other car, let's suppose it's this car, for example, in the same time will move in this direction. And this happened if the two cars move in this direction, two cars, if we take two cars or three cars, whatever the number, and this car move here, and this car move here, okay, and this car move here, and the other side will have the same number, 1, 2, 3, 4, and 1, 2, another one moves here, and another one moves here, and the third, fourth one moves, for example, 1, 1, 1, 1, 1 that appears here. I want someone, this one, for example, will move in this direction. So there are movement on both sides all the time. One moves in this direction, another one moves in this direction. 4 move to the north, 4 moves to the south. The same number moves to the south. The total number can't be the same, maybe. You see, the total number here will be the same all the time, and the total number here will be the same all the time. Okay, let me make it in green so you can see it. So if you notice here, the total number is not equivalent, is not the same, but it will remain constant. Why it remain constant? If you notice, the number of cars in the south direction are greater than this one, but at some point, at equilibrium point, when the number of car passes in both directions are equal, we equilibrium or mechanical equilibrium, the number of cars on both sides will remain the same, the same. So this is similar what happens in chemical reaction. The concentration are not equal, but they are constant. All the time if we reach the equilibrium point. Okay. So that explains the meaning of equilibrium. Mechanical equilibrium, exactly. We call it mechanical because there is movement all the time. And equilibrium because the number of cars on both sides are constant. They are not equal, but constant. Abdelhadi?
Yes, Mr. Yes.
This slide.
Okay. Under what conditions do physical and chemical equilibria occur? When a physical change does not go to a completion, a physical equilibrium is established between the forward and reverse changes.
Yes. Equilibria is the plural, Abdelhadi. Equilibria is the plural of equilibrium. Equilibrium, singular. Did you start recording? I think that we have started recording, but let me just be sure. Yes, we are recording. So, the word equilibrium is singular. The plural of it is equilibria. Under what condition do physical and chemical equilibria occur. So we have explained the chemical equilibrium. The same applies for physical equilibrium. We'll talk about it in a while. It has the same condition. It can be reached. The previous image here indicate a physical equilibrium, by the way. Okay. When a physical change does not go to the completion, a physical equilibrium is established between the forward and reverse change. Remember, when we talk about physical, we say change, not reaction. It's a physical change. And that is the definition of equilibrium. Abdullah Abdul-Baqi. Abdullah Abdul-Baqi.
Yes, Mr.
Read this slide, Abdullah.
Second, بدلي.
Equilibrium is a state in which the forward and reverse paths of change take place at the same rate. Balanced traffic at a toll bridge is a model for a system of equilibrium. When opposing physical change take place at the same time, a physical equilibrium is reached. When opposing chemical change take place at the same rate, a chemical equilibrium is reached.
So it's rate, not time, ya Abdullah. Rate, the same rate. So balance traffic at the toll bridge. The previous image is model. This image is a model of equilibrium. Is a model for a system in equilibrium. Again, we said that the number of cars on this side is constant, and the number here is constant when we reach equilibrium. And they are not equal, as you see. They are not equal. And we can present it here. If 4 cars move to the north, 4 cars again move to the south, we will assume that this one is the forward direction and the red one will be the backward direction. When the rate of the forward direction equal to the rate of backward direction, so we will have the same number of cars in this side, the north side, and the same number of cars on the south side. Same number means same number with time, over time. But if you compare them with each other, if you compare number of cars here with the number of cars here, they are not equal. But they are, each one individually is constant over time. So if we have 10 here, they will continue to be 10 over time. If we have 100 here, it will be continue to be 100 over time. This is the meaning of constant. But they are not equal. But they are not what? They are not equal. So this is mechanical equilibrium, not static equilibrium. In the mechanical equilibrium, there is a motion, there is a movement, there is forward direction and backward direction happens all the time. But the two rates in opposite direction are equal. That's why we have an equilibrium. Abdullah Abdul Latif. Abdullah Abdul Latif. Abdullah الدحيلان.
Yes, Mr. Here.
لطيف ولا الدحيلان؟
Mr. I have delay. I can't see anything.
عبد الله الدحيلان ولا عبد الله الدحيلان انت صح؟
Yes, Abdullah Dihilan.
اوكي عبد الله الدحيلان. Read this slide, Abdullah.
Type of equilibrium. Equilibrium is a state in which the forward and reverse path of change takes place at the same rate.
We are slide, Abdullah. We slide.
Mr. I have delay. Okay. Physical equilibrium. Liquid water left in a closed container eventually reach equilibrium with its vapor when the rate of evaporation equals the rate of condensation.
So this must be a closed system. To reach equilibrium, it must be a closed system, even physical or chemical. So this is closed system. The system of amount of water and water vapor here. This is water and this is water vapor. We will reach an equilibrium. Look here. 2 moves as a gas and 2 gas condenses to water. So this is equilibrium. Liquid water left is closed container eventually reaches equilibrium with its vapor. So the liquid water will reach an equilibrium with its vapor when the rate of evaporation equals to the rate of condensation. Rate of evaporation represented by this arrow and this arrow. forward, upward. Let me take it and represent it for you. And that's it. So we have here liquid water. This is liquid water, as you see. This is liquid water. And here you will find the vapor of this water, the particles of the vapor. Okay. And this is closed system. As you see, it is a closed and sealed system. So the equilibrium can be reached. Here we'll see the number of the evaporation. Evaporation, we represent it in red. This arrow and this arrow represent the rate of evaporation. When the rate of molecules of water that evaporate, the molecules of water that is, I will represent it in blue. We said an equilibrium have been reached for the physical change. For that physical change. Thank you, Abdullah Dehlan. Abdullah Mubarak.
Yes, Mr.
Okay, Abdullah, I want you to. Okay. You read the next slide. Read this slide, Abdullah.
Okay. Liquid water in equilibrium with water vapor can be described by this equation. The slash stands for liquid and G stands for gas. The pair of arrows in the question indicate that the forward change and the reverse change happen and at the same rate.
So they will be at the same rate when they reach equilibrium. L here, H2O, and we type L beside it, it's subscript, small one, because it's liquid. It stands for liquid. And G stands for gas. And there is, both of them are water. This is not chemical reaction. That is a physical change. Water, water, we didn't change it. We only change the state. So this is a physical system, or a system that is in physical equilibrium. The rate of forward change is equal to the rate of backward change, not reaction. I said change. Abdurrahim Adil.
Yes, Mr.
Abdurrahim, read the slide.
Okay. Chemical equilibrium.
Equilibrium.
When a chemical reaction does not go to completion, a chemical equilibrium is
established
between the forward and reverse reaction. Most reactions are reversible to some extent.
Yes.
A reversible reaction is a reaction in which the conversion of reactants into
conversion of reactants
into product and the conversion of product into reactants can happen
simultaneously. So he's explaining two different concepts here. Let me remind you with them. I said previously that there is some chemical reaction go for completion. It's not reversible, like carbon plus oxygen will give us one arrow, one direction, CO2. This is a chemical reaction that can't reach equilibrium because it goes only in one direction, as you see. Another chemical reaction, N2 plus 3H2. This reaction goes in this direction to form 2NH3. So nitrogen react with hydrogen and they produce the ammonia gas. Ammonia gas can dissociate and goes in the opposite direction. and let me represent the opposite direction by another arrow. This is the opposite direction. So we have, this is a reversible reaction. The reactants can go to form products, and the products can go the other direction to form reactants one more time. So this is reversible reaction. This is not reversible reaction. Equilibrium can be reached here and cannot be reached here. Okay, equilibrium cannot be reached here. So let's type, delete this. So you don't think it's wrong, it's right, but this is the reaction for equilibrium. بعد كده أدهم.
Yes, Mister.
Read this slide, Adham.
Okay. Types of equilibrium. In the synthesis of sulfur trioxide, the forward reaction produces sulfur trioxide. Some molecules of sulfur trioxide change back into the reactants by the reverse reaction. During chemical equilibrium, the reactants change into products just as fast as the products change back into the reactants.
Yes. During chemical reactions, the equilibrium, the reactants change into products just as fast as this is when you reach equilibrium. Forward reaction will be equal to the backward reaction. One thing I want to say it here, that the equation is balanced, no problem. So this is similar to the equation that we take it previously. Let me just, if I can take it here, Control C, and put it here, Control V. So it's the same as the previous equation. It's exactly like the equation of nitrogen here, this equation. So that's sulfur dioxide plus oxygen will give us sulfur trioxide. All of them are gases. And this is a reversible reaction, like the synthesis, like the reaction of synthesis of ammonia gas. أحمد متعب القناص. أحمد متعب القناص.
Yes.
Read the next slide, Ahmed.
What?
I read this one and you will read the answer. How do equilibrium system respond to change? Le Chatelet principle. Read this, Ahmed.
Okay. When a change is introduced to a system in a equilibrium, the equilibrium shifts in the direction that relieves the change. The rules was first observed by Henry Le Chatelier.
No. Henry Le Chatelet, French scientist.
Today, the rule is known as Le Chatelier's principle.
Le Chatelet's principle. So this rule is the rule of Le Chatelet. When a change, and this is the state of this rule, statement of rule, the text of the rule. When a change is introduced to a system in equilibrium, the system is in equilibrium. The equilibrium shifts in the direction that reveals the change. Thank you, Ahmed. Let's make another one.
Mr. did you say my name?
Not yet.
Okay.
Not yet, محمد. علي يوسف الهلال. علي يوسف الهلال.
Yes, Mr.
Okay, Ali, read this one. Factors affecting chemical reaction.
Okay. When a change is introduced to a system
No.
in
We change.
equilibrium.
Sorry. You have a delay. I need the second slide. The second slide. Another slide. Do you see it? علي يوسف الهلال. سقط مننا علي. فيصل.
Yes, Mr.
يس ايه بعد سنة بتقول لي يس. Do you see it? Do you see the slide? علي. Again, you go back again. You go away again. طيب, leave علي alone right now. فيصل فهد. فيصل. حسن رمضان. حسن عبد المجيد رمضان.
Yes, Mister, I'm here.
Okay, Hassan. I want you to read this slide.
Okay, Mister. Factor affecting chemical equilibrium. The making of ammonia is an example of a process in which chemists apply Le Chatelier principle
Le Chatelier
into
principle. Le Chatelier principle.
G plus 3H2G
Gas. G
equal
means
to
gas.
H3
Hassan.
if a system containing nitrogen, hydrogen, and ammonia is in equilibrium. You can predict how the system will be affected by change in temperature, pressure, and concentration.
So he's talking here about the factors that will affect this system. This system is at equilibrium. Nitrogen reacts with hydrogen and give us ammonia gas plus heat. So this reaction will be affected by the temperature, pressure, and the concentration. Let's see how temperature affected. Thank you, Hassan. Ibrahim Adil.
Yes.
Ibrahim, read this slide, temperature.
Temperature. In this equation for the synthesis of ammonia, heat is written as a product. The forward reaction is exothermic. In the reverse reaction, heat is a reactant. So the decomposition of ammonia is endothermic.
So this reaction, forward reaction, produces heat, so it's exothermic. The forward reaction here, which produces ammonia, it will produce also heat. But the backward reaction, it consumes heat, so it's endothermic because it will use heat. Heat is a reactant in the backward direction, so backward direction is endothermic. If we added heat, what would happen? Let's pick someone to answer this. Ibrahim Anwar. Ibrahim Anwar.
Yes.
Okay, Ibrahim. Read this slide.
From the beginning.
Yes, this slide. According to
Le Chatelier
Le Chatelier principles. Le Chatelier's principle.
Chatelier's principle, if you added heat to the system, the
Equilibrium
would shift in the direction that removes heat from the system. The system would favor the reverse reaction, which is endothermic. By increasing the temperature, you would decrease the amount of ammonia.
Yes. So if we come here and we increase the temperature to this, we explained it yesterday. So if we increase temperature, the reaction will try to reveal this change. So it will go in direction that consumes heat, which is the reverse direction, consumes heat. So this direction will consume heat. So I will decrease the amount of ammonia gas if I increase the heat. Thank you, Ibrahim. After this pressure, sorry. Ibrahim Rabia. Ibrahim Rabia. Muaz.
Yes.
Read this pressure. Slide about pressure, Muaz.
Yes. Pressure.
You are lagging, Muaz.
Okay. Pressure. According to Le Chatelier principle, if you increase the pressure, the equilibrium would shift in the direction that decreases pressure of the system. In order to increase pressure, the system would favor the reaction that produces fewer gas molecules. By increasing the pressure, you would shift the equilibrium to the right, producing more ammonia.
So pressure means if you decrease pressure, the system would favor the reaction that produces fewer gas molecule. So let's go back to the reaction. If I increase pressure here, if pressure, the reaction favor to increase. If you increase pressure, he will decrease pressure. So it will go for forward direction, which will give fewer amount of molecules. We have only 2 here and we have 4 here. We have explained that before. No need to repeat it again. So what's happening by increasing pressure? If I increase it, the reaction will prefer to decrease it or reveal the change, which means he will try to decrease pressure. For the reaction to decrease pressure, it will move in the forward direction, which introduces more ammonia gas. And the opposite happens if we decrease pressure. If we decrease pressure, the reaction would prefer to go in the direction that increases pressure, which is the backward direction. Because it will produce 4 molecules instead of 2 molecules of ammonia gas. So pressure is related to the number of molecules. Concentration, last one. Muammal.
Yes.
Read this one, concentration.
Concentration. Aristoteles' principle tells you that if you decrease the ammonia concentration by removing ammonia from the system, the equilibrium would shift in the direction that produces ammonia. In order to produce ammonia, the system would favor the forward reaction.
Yes, if you want to increase or if we take the ammonia gas, take it out from the medium of the reaction, so we are decreasing its concentration. If we do that, the reaction will try to reveal our change, which means it will move in the forward direction to produce more ammonia, to replace that ammonia that we take it from out of the medium of the reaction. So we have come to an end. I'll give you a quiz about that. Just 1 minute. Equilibrium. That's equilibrium. And right now we're ready to take this one. Let's start. Copy. And let me see your intelligence, guys. That's the quiz. Quickly join it. I want to see how many one will be the better student that will have the greater marks. Join the quiz quickly, guys. We don't have much time. We have only 6 minutes. Let me start the quiz. So. Muhammad Ayman is here. Muhammad Ayman al-Milhim. Muhammad Ayman. محمد عبد الباقي. محمد عبد الباقي.
Here.
Okay. محمد أيمن is absent. طيب. أحمد رمضان.
Yes, Mr. I'm here.
Okay. محمد فضل.
Yes, here, Mr.
مرتضى. absent. نفجان. absent. أسامة فراس. absent. سعد اليامي.
Mr. I'm here.
Okay. سعد خالد الحسيني. علي كمال المرزوق. علي كمال absent. So I will call the names that are absent. علي كمال حسين المرزوق absent. سعد الحسيني absent. أسامة فراس absent. نفجان absent. مرتضى absent.
Mr. Murtaza is here.
You didn't answer me in the first place. محمد أيمن is absent. محمد أيمن الملحم absent. إبراهيم الربيعة absent. فيصل absent. فيصل فهد المحيش absent. عبد الله العبد اللطيف absent. عباس absent. All of these are absent. علي يوسف الهلال is here.
Mister.
Yes.
I think Abbas is here, but I think he have a mic problem.
Can you write in the chat area?
No, because sometimes he have mic problem.
Writing in the chat area. Typing. Don't forget to do the project, guys. If you have any question about the project, go to Classera. We'll find a video about projects. You can listen to it. And the beginning only of the video is about the project. You can listen to how you can make a project and what exactly we want. We don't want research. We don't want a presentation. We want something physical. Okay, we want something physical.
Mister, the project was about
any topic you choose it from the previous chapters. We covered from chapter 3 until we finished today chapter 7. Okay, this is the last topic and chapter or last lesson in chapter 7. So choose anyone and make a project about it. Go to the video on Classera, listen to how to make the project. You will see how can you make a project and what exactly do you want of this project. Then you start to do it, and inshallah you will find it quickly. It's easy to do it, not difficult. Okay, guys? Okay. We have come into our session today, guys. I hope that you have enjoyed the session and see you tomorrow, inshallah. Bye-bye.